Hi, I'm Steve, and today I'm going to take you through the guide on our docs on how to train and run an ML model inside Quix. So the first thing to note is I'm logged into Quix and I've got empty workspace, so I haven't created anything yet. I've also got Jupyter Notebooks installed on my machine, and that's up and running with all the dependencies mentioned in the docs page. So the first thing I'm going to do is to import all the things that we'll need in our Jupyter Notebook. So I'm just going to copy these in from the tutorial. So we've got a whole bunch of imports here which we'll be using in the process of training a machine learning model. So as you can see, that ran fine, so I've got everything imported and installed correctly. Next up, we need to grab some data from inside Quix. So that means we need to have some data inside Quix. So let's go over to Quix, and we're going to follow what would be the quick start guide. So for example, if I click here, add data source, the recommended onboarding data source is this demo data source, which, as it says here, is a stream of F1 telemetry data. So what I'm going to do is just simply click set up and deploy. I don't really care about the data in this case, so we'll just deploy it and just know that there's a whole load of data in there, which we will have a look at once it's deployed. But essentially we don't really care about what the data is, we're just looking at how to deploy a machine learning model in Quix. So once that's up and running, we can see that we've got a service running in our pipeline, and if you hover over the arrow you can see approximately how much data is being transmitted to the next stage in the pipeline. We don't have a next stage yet, and that's fine. So what we can do is click on the arrow and we can explore the live data. So we can see that we've got the F1 data topic selected. So if we now select the stream that we've got there, and then we can select, let's say, the brake and engine RPM, and we can see here that we've got some data coming in. We can see that the engine RPM is going up and down, and we can see that the brake is being pressed. We basically get a value of 0 or 1 for the brake, and obviously a very much fluctuating value for the engine RPM. In order to train our machine learning model, we need to work with persisted data to begin with, rather than this live data. So if we head over to the topics page and then turn on persistence for this topic, this will ensure that the data is stored to our time series database, and we need to do that temporarily so that we can actually extract the data and use it in our Jupyter Notebook. When you're up and running and everything's working fine, you can turn off that persistence and save that resource cost. So if we head back to the Data Explorer and ensure that you're clicked on the Persisted Data tab, so what we can do now is add a query to look at the data that we then want to use to train our model with. So I'm going to click Add Query, ensure that we've got the F1 data topic selected. If this was an empty workspace, you'll only have one topic anyway. At the moment we've only got one stream, so I'll just choose that one. And then click Next. So I'm going to choose the brake parameter because we'll be predicting when the brake will be pressed. In order to train that model though, I'll need some additional parameters as well. So I'm going to choose world position, gear, speed, and steer. Then when I click Done, I can see all of those values shown in the waveform here. Now what I want to do is ensure that we're not aggregating this data, so we just want the raw data, and then we can either view this data as a waveform like we're doing now, or we can view it in a table, or indeed we can get the code to actually work with that data in our Jupyter Notebook. So we can see here that we're going to make a call to an API called the Telemetry Query API. It's one of Quix's several APIs that we can use, and this one will allow us to get the data. So what I'm going to do is copy this code, head over to my Jupyter Notebook, and then simply paste the code in, and then I can run the code. And as you can see, what I get in my Jupyter Notebook is the results that we saw in the table view in Data Explorer. And that's fantastic. We can now carry on with the next bit of our notebook. So what we're going to do is paste in this preparation step. So the next stage is to convert the break value to a Boolean value. So at the moment it's a value between either, I think, -1 and 1. So we're going to convert that to a Boolean. So again, run that stage. There was no output, so we didn't see anything. So the next thing we're going to do is paste in the next code snippet. And what this is going to do is create this break shifted by 5 seconds column in our data frame, so that we can essentially predict the breaking 5 seconds ahead. Again, we'll run that. So now we get to actually see some output in the form of a plot. So we're going to output the break Boolean and break shifted values into a plot and see what we get. So as you can see, we've got our break and break shifted. The break shifted is ahead by 5 seconds. So now we're just going to perform a simple calculation to do some weighting on the break shifted value. We can run that and print it out. Next up is the kind of meat of this machine learning process, and we're going to paste that in from the tutorial. And we won't go through this line by line, but essentially we are taking the values from our data that we've collected from Quix, and we're going to use MLflow to actually train the model. So if we actually run that code, we can see that, well, there was no output apart from these kind of warnings. We can now print out the model accuracy value and see what we get. So we can see there that we've got some data as expected, with an indication of the training and model testing accuracies. What we're going to do now is another plot showing the predicted braking value versus the actual speed of the car. So again, I'll paste in the snippet from the tutorial, and when I run this, we can see that we've got another plot, and this is showing the braking prediction slightly ahead of when the car actually slows down, so that we can see that the speed of the car drops off heavily, and that is as a result of this braking. Now, this isn't meant to be the sort of best machine learning model ever created. The idea is to show you how to actually get the data from Quix and then run your machine learning model. In the next phase, we'll be running the model inside Quix in real time. So the purpose of this part of the tutorial is really just to get the model as an output. So with that said, the last step is to actually get the model and have it saved to our machine. So I'm going to call this precision tree 5 depth, and I've already got one of those, so I'm going to add on here demo. So now when I run this, it will save that to my machine. So again, if you're running this demo on Windows, this decision tree file will be saved to your users folder. Now, in order to be able to run this model inside Quix, we can go back to Quix, and then we can head over to the library, where we can filter the library by Python and transformation, and then we're looking for this data filtering model transformation. If you don't see it immediately, you can search for it using the search functionality, and then basically what we're going to be doing is clicking on this tile, and we can see at the moment that essentially what happens is this Quix function receives pandas data frames. So every time our F1 data topic receives some data, we will receive a data packet in this pandas data frame handler. And then this is where we're going to be running our model that we've just trained. So at the moment this code is just in the library, we can't edit it here. What we need to do is click Edit Code. I'm going to change the name of our project because what we're going to be doing is saving this code as a project. So I'm going to change the name of the project to Break Prediction. I'm going to choose an input topic of F1 data, and I'm going to change the output topic to Break Prediction. So we're going to receive data from the F1 data topic, and any data going out is going to go into our Break Prediction topic. So I'm going to save that as a project. This is now saved to our projects list inside our Quix workspace. So we've got one project, Break Prediction. So the first thing I'm going to do is upload the model file we generated in our Jupyter Notebook. So I can click the Upload File button, and then in my Users folder I can paste in the name of the file that I want to upload. So I'll click Open, and that will upload the file. Now it doesn't look like anything inside the Quix code editor because it's not a plain text file. Now you will notice that the editor is saying that I've edited this file. So when I click off, I want to be sure not to commit these changes. The reason that's doing that at the moment is because it's tried to make the file viewable, and in doing so it's changed some of these special characters. So essentially do not click Save and Commit, because that will commit these changes that we don't want to this model file. So we'll click Do Not Commit. So that model file is now as it was on our computer. So what we want to be doing is editing the Quix function file and making it so that it will run our machine learning model. So first off, I'm going to add the imports that we need, which is pickle and math. Next, I'm going to be loading the pickle file that we uploaded to our project earlier. So that will go into the init function. Then underneath the init function, I'm going to be pasting in a function to do some pre-processing. So that's this pre-process function. I need to fix the tabbing. There we go. So this will essentially get the correct output by pre-processing the data. So we're going to be setting some limits and then returning that data frame back to the event handler. So I'm going to replace this entire Panda data frame handler with the example from the tutorial. So I'm just going to remove that and paste in the new handler. I again just need to tab that in one more tab. So basically, as I said before, this Pandas data frame handler is going to be triggered or run, executed, for each new data item coming in from the F1 data stream. The parts that are kind of worth mentioning are that we're interested in these parameters, and we're going to output the break prediction shifted into the future by 5 seconds. The break prediction is going to come from the model, and what we're also going to do is merge the original break value into the output data frame using the Pandas data frame concat method. So what that will allow us to do is see the real-time break and the predicted break on the same output later on. Head over to the main Python file, and what we'll do is we will change the output stream, by default this sample is set up to detect hard braking with a very simple detection method that you might have seen in the Quix function. So now what we want to do is change it so that it's actually detecting or predicting braking. So we'll change the output stream to be a combination of the input stream ID plus predicted braking. So with that change made, all we have to do is ensure that the Quix function is actually referencing the correct file name. I think I copied in decision tree 5 depth, and my file is called -demo. So there's one final change that we need to make. We're using sklearn, and we need to ensure that the requirements file is bringing that in and making it available for the Python code to use. So I will add sklearn to the requirements text file. I will use Control-S on Windows to save it. And now you can see down here in the bottom right that Quix is actually downloading and installing sklearn into our sandbox environment. So with that completed, we can now click Run, and we should see the debug output, or the lines that we put into the Quix function, being displayed in the output here. So as you can see, we are looking at the output from our prediction, and sometimes we get 1, sometimes we get 0, depending on what the prediction is. So with that running successfully, what we can do is stop the code, and then we can deploy it into our Quix workspace so that it runs continuously. By default, the deployment settings are on service, which means that the code will run continuously and recover from any failures. We don't really need to give it more memory or replicas or any more CPU, but if you've got a particularly intensive machine learning model, you could increase those values so that it runs quickly and efficiently. I don't need to make any changes, so I'm just going to click Deploy. We'll be redirected back to the home page, where we'll see that the code is being built, and then it will be deployed and start running. Once that code is up and running, it will be started and it will start processing and running the model. So we'll be able to click on the arrow and then go and explore the live data coming out of the service. So let's do that. So we'll make sure that the break prediction topic is selected. We will select the stream. You should have only one stream. And then you'll notice in the parameters available on that stream, we've got the break and the break prediction, which is what we put in there in the code. So we'll select break and break prediction. And I'll just move myself to the other side. So here, as you can see, we've got the break prediction. I'll just pause this a moment. We've got the break prediction and the break actual value. The prediction is in blue and the actual value is in green. So here we can see that our model is doing a fairly decent job. It doesn't always do a fantastic job, and that's because I essentially trained the model on such a small data set. But the purpose of this exercise wasn't to train a fantastic model. It was to show you how to actually train your model using data obtained from Quix, and then actually run your model inside Quix on data in real time. If you have any questions about this tutorial or anything else stream related, you can join the stream, which is our Slack community, and ask any questions you have, or tell us about the project you're working on, or just send us funny memes on whatever you want. So yeah, thanks a lot. Thanks for watching. Hopefully you found this useful, and we will see you in the next one.